This video will go over how to solve and then graph the solutions to some of these inequality problems. Okay, so to solve an inequality, it's kind of like solving an equation. So you kind of use the same strategy, except you are going to have an inequality at the end. So I'm going to just pretend like it's an equation, and I'm going to solve this by doing the opposite operation on both sides. So then I have x and I have 1 here. So now my solution is 1. So I'm going to put 1 on the graph because that's my solution. And so then I'm going to put, I look back at the beginning and I see that this is a less than symbol, so that's an open circle. So I'm going to put an open circle at 1. And then what I'm going to do is I'm going to check both sides of this number line on 1. So either the solution are the things that are less than 1, like 0 or -1, okay? Or the solution is all the values that are greater than 1, like 2 or 3. So I'm going to check both of those things. So I will start with less than 1. So I'm going to use 0. So I'm going to put 0 in my inequality. I'm going to like RSS it, except I'm just going to SS it. So 0 plus 5 is that less than 6? And yes, it is, because 5 is less than 6. So this side worked. Now I'll try the other side. So I'm going to say, well, let me try, I could pick any number over here. I'm going to pick 3. So 3, if I put 3 in this inequality and replace this x with 3, is 3 plus 5 less than 6? No, 8 is not less than 6. So that means 3 does not work in this inequality. And 2 won't work because 2 plus 5 isn't less than 6, and 4 won't work. So nothing on the right will work. So that means my solutions are everything to the left. So the solutions for this inequality are the things on the left. So those are the things that are less than 1. And there you go. There's my solution. X is less than 1. So I'm going to show you 2 more. Okay, so this one here is a subtraction problem. So like we did with the equations, I'm pretending like it's an equation. So I'm going to do the opposite operation, which is addition. So I'm going to add 2 to both sides. And then I have x, and over here I have 6. So 6 is part of my solution. And I look and I see that it's only greater than symbol, so there's no line there. So I leave an open circle. Because if there was a line underneath, I would do a closed circle, but it's open. And then 6 is my solution. So I'm going to look, there's numbers that are less than 6, like 4 and 2. And then there's numbers that are greater 6, then like 8 and 10. And I'm going to check both sides of this inequality. So let me start with a number that's less than 6, like 4. So I'm going to put 4 and I'm going to plug that into this. I'm going to substitute and simplify. So 4 goes in there. So it's 4 less than 2. 4 minus 2, is that greater than 4? So no. So when I used a value over here on the left of 6, it did not work in my inequality. I got a value that was not greater than 4. So let me try the other side. And I'll choose 8. Okay, even though it doesn't look like an 8, it's an 8. That's 8. So 8. If I substitute 8 in for here, if I say 8 minus 2, is that greater than 4? And yes, 8 minus 2 is 6, and 6 is greater than 4. So that means the numbers on the right of 6, they are solutions to this inequality. So my graph is going to have an open circle at 6 and an arrow pointing to the right, because all the values on the right are going to work. So that means that x, so I look at the symbol, see x is greater than 6. So these symbols from the original have actually been the same in the solution. That won't always be true. I'm going to show you right here for number 4, okay? So here in number 4, I have my x on the right, so I look at what's being done to the variable. It's being subtracted, so the opposite of subtract is to add. So I'm going to add 10 to both sides, and then I get 12. And I have over here x by itself now. Okay, so at 12 is my solution, so I'm going to put 12 on my number line. And this time, since it has a line underneath the less than symbol, it's less than or equal to, so I'm going to color in the dot here at 12 because it's also equal to 12. And now I'm going to check something that's less than 12, like over here we have 10 and 8. And I'm going to check things that are greater than 12, like 14 and 16. So let me start with something that is less than 12, like 10. So I'm going to go back to my original inequality, which says 2 is less than or equal to x, but I'm using 10. So 10, and then minus 10, minus 10. Well, 10 minus 10 is 0. So is 2 less than or equal to 0? No. So then the stuff on the left, the numbers on the left are not going to work. So let me try the other side. Let me try something like 14 on the other side of 12. So now I'll try a 14. So 2 is supposed to be less than or equal to x, but I'm using 14 for x, minus 10. Well, let me simplify the right. 14 minus 10 is 4. So is this true? Is 2 less than or equal to 4? Yes, 2 is less than 4. So this is true. So all the values to the right of 12 will work. So 16, if I put 16 in there, 16 minus 10 is 6, and that is also. So here is my arrow. Now look at how the arrow is pointing to the right. So that means my solutions are all the things. So x must be greater than or equal to 12. So this time, my symbol did not go the same way. So my solution is x is greater than or equal to 12. So that's how you can use the graph to know which way your symbol goes and how to graph and solve your equations or inequalities. I'm sorry. Thank you.